Okay, so question number 4 says, what are some examples of a buffer solution? So let's define what a buffer solution is. So a buffer solution resists drastic change in pH even upon small additions of strong acid or strong base. So for example, let's say we had a solution of water. If we added the tiniest amount, like let's say like a drop of a strong acid such as HCl, like a highly concentrated HCl, then the pH of that water would decrease significantly upon that one drop of a highly concentrated acid solution. But when we have a buffer, it tends to resist this drastic change upon small additions of strong acid and base. So we can have different buffer solutions. So one example is a mixture of a weak acid plus its conjugate base, or we could have a mixture of a weak base and its conjugate acid. So an example would be hydrogen cyanide, which is a weak acid, plus its conjugate base, which is the cyanide ion. This would make a buffer solution. And the junior tutor said that a buffer is a solution that can resist drastic changes in the pH on the addition of acidic or basic components. In a buffer solution, only a small amount of the acid or base ionizes into the solution, thus maintaining a relatively stable pH. It is commonly used in processes that require stable pH ranges. Basically, a buffer solution should contain a weak conjugate acid-base pair, which means that it can be a combination of a weak acid and its conjugate base, or a weak base and its conjugate acid. Following are examples of a buffer solution. So you could have acetic acid, which is a weak organic acid with the formula CH3COOH, and a salt containing its conjugate base, the acetate ion. So this is like sodium acetate, CH3COONA. Pyridine is a weak base, and a salt containing its conjugate acid, the pyridinium cation, such as pyridinium chloride. Or lastly, you could have ammonia, which is a weak base with formula NH3, and a salt containing its conjugate acid, the ammonium cation, such as ammonium hydroxide. Yep, so this solution is correct.